Math 3 Lesson Summary Video. Getting Centered. This lesson is a solidify understanding task, which takes concepts developed previously and helps you formalize these ideas. The purpose of this lesson is to use the equation of a circle in multiple forms and convert back and forth. Malik wrote the equation of one of the circles, and just because he likes messing with the algebra, he did this. Original equation, x minus 3 squared plus y plus 2 squared equals 225. What you'll notice that he did is he remembered what it meant to be a binomial squared. He went and actually expanded out x minus 3 times x minus 3 and did that multiplication and found out that it was x squared minus 6x plus 9. He did the same thing for y plus 2 squared and expanded it to y plus 2 times y plus 2, and got that that was y squared plus 4y plus 4. The 225 didn't really need any changing at the moment. Then he decided he didn't really like the way that was ordered, so he wanted everything to go by highest exponent. So he went alphabetically, x squared, then y squared, and that got all the squared components. Then he put all the x's and y's, not squared, again, alphabetically, so x's before y's. And then he did have to subtract 225 from both sides. And we already had a 9 and a 4, so that was 13. And then 13 minus 225 is where that negative 212 came from. This is the vertex form we are familiar with from parabolas, square roots, all of the other graphs from Math 2 that you graphed and learned transformations. Circles don't really have a vertex, though. They have a center. And so some people call this the graphing form, the center form, or the vertex form. When you multiply it out and you get all of the individual terms, remember we refer to this as the standard form. So these are the different forms of the equation of a circle. So you have your center form, your graphing form, or your vertex form, but it doesn't really have a vertex, but it's the same idea as our vertex form. And you have your standard form. Now also notice when it's in standard form that they made it equal 0. That's a very polynomial thing. Remember, we always liked our polynomial equations to be equal to 0 to solve them, and so we tend to get them equal to 0. So it just moves everything over to one side of the equation and gets it equal to 0 on the other. Malik thought, that's pretty cool. It's like a different form of the equation. I guess that there could be different forms of the equation of a circle, like there are different forms of the equation of a parabola or the equation of a line. He showed his equation to his sister, Sapana, and she thought it was nuts. Sapana said, that's a crazy equation. I can't even tell where the center is or the length of the radius anymore. Malik said, now it's like a puzzle for you. I'll give you an equation in the new form. I'll bet you can't figure out where the center is. Sapana said, of course I can. I'll just do the same thing you did, but I'll work backwards. Malik gave Sapana this equation of a circle. X squared plus y squared minus 4x plus 10y plus 20 is equal to 0. Help Sapana find the center and the length of the radius of the circle. So she said she was going to do what Malik did, just backwards. So we have to think about what Malik did. Remember, he did move that constant from over here. The radius was over here. So this number, we really want it to be on this side of the equal sign. So we're going to have to subtract 20 from both sides to do that. Now, we don't know what was over here that he had added that number to, and that's something that we're going to have to figure out over here. So now we have x squared plus y squared minus 4x plus 10y, and it's equal to negative 20. Now, negative 20 doesn't make any sense for a radius. Radius is a length, and it's something that's been squared, so it shouldn't turn out to be negative. So I know something's up. But I also noticed that this isn't arranged the way Malik had it in his second form. He had all of his x's together and all of his y's together. So I think I just need to rearrange. Now, I'm not moving anything from a different side of the equation. I'm not changing any signs or anything. I just don't like the way everything is ordered. So if I just put my x's so that my x's are next to each other, and then I put my y's so my y's are next to each other, and then I've still got it equal to, and I've still got it, that negative 20 over there. I also realize I'm missing something. In Malik's form, he had a constant number here. And he also had a constant number here. It was that constant that he got when he multiplied out that square binomial. And that started making me think. Square binomials. Where did we do squared binomials in Math 2? And I remembered it was when we were putting parabolas in vertex form, when we had standard form. And we used a tool in our toolbox called completing the square. And so I want to try and use that tool to help me figure out what was this number before it got messed up by the radius over here. Whatever the radius had been, we ended up subtracting it from both sides, and we ended up with this negative 20 or 20 over here. We need to know what these two numbers were. And I remember for completing the square, you always take half of b and then you square it. So if I take half of negative 4, that would be negative 2. And negative 2 squared is 4. But I can't add 4 on this side of the equal sign unless I balance it out by adding 4 on this side of the equal sign too. So we want to make sure we keep things balanced. So when I added 4 here, I had to add 4 over here as well. Now I want to try and complete the square again. Half of 10 is 5. 5 squared is 25. So that means that these numbers must have originally been 4 and 25, but I want to make sure I put them back over here. So on this side, it means that we must have originally had 29 plus negative 20 is actually just 9. So our radius squared was equal to 9. I also have to remember that when I'm completing the square, the whole point of it is that now I have a perfect squared binomial. Whatever this pattern is, it's always going to be a perfect squared binomial. And we know that we can write it with that b over 2 part. So half of negative 4 was negative 2. So this must have been x minus 2 squared. Half of 10 is 5. So this must have been y plus 5 squared. Multiply it out. If you don't believe it, it would be negative 2x and negative 2x, which is where the negative 4x comes from, and negative 2 times negative 2 is 4. 5y plus 5y would give us the 10y, and 5 times 5 is 25. So that means that our center must be at 2, negative 5, and we must have a radius of 3. If you think about your steps that Sapana went through to do this, just doing what Malik did backwards, the first thing she did was she moved the constant over to the other side because we wanted to put it back. He had moved it over last, and we wanted to move it over first. Then she had to rearrange the terms because the x's and the y's were all mixed up. We needed to get our x's together, and we needed to get our y's together. Then she used completing the square, that really helpful tool that we learned last year, to help figure out what must those constants have been before they got messed up by the radius. And then after she did that, she actually factored them into their perfect square binomials. And now we have our graphing form